Good morning, everybody. In a previous session, we started off with the discussion regarding data types, in which we discussed regarding say net data types, registered data types, then integer and real and time register data types. So these were the few things what we had discussed. So in continuation with the same, we'll be going for the rest of the part. So next data type which we'll be discussing is it will be array data type. So in previous classes we discussed regarding integer, real, and time register data types. So and how we declare it and how do we invoke those things. So those all things we have discussed. Now next one which comes is arrays. Arrays is a collection of say similar kind of elements. So that is what we have seen in C programming. For example, if I have say some 10 numbers which are in its decimal notation, that is those are floating point numbers. So if I club them in one set, that I can call it as a array. So all the elements in this array will be of similar kind. So in this one also we have something in same format. So let us see what we can just have and what are the different things we can observe. Actually, we have done it. We have uh, we have used it, but this is just a concept what we are learning over here. So for example, in our case, what we have binary numbers, we have hex numbers, we have say then we have different numbers, octal numbers. Then apart from this, we have integer type, reg data type. So these are just a few things to name. Then we have wire. So these are just few things to name. So these all I can have arrays of these these data types, and under which I can have these categories: octal, decimal, binary, hex. So these are a few things which we can have. Now here, if you just observe, there are some restrictions when we go for Verilog. So here, the first thing which comes is basically Verilog supports arrays, but what type of arrays? So it will support arrays of register data types, integer data types, time data types, and vector register data types. For these elements, arrays are supported. So as we specified, wire or net, it doesn't support for that one. Arrays are not supported for those cases. But we'll be writing something as 7 down to 0. So these all things also come in. So there we can have a check as to how it goes around. So arrays are restricted to these data types in Verilog. Here, another one restriction which comes is we also have to deal with numbers like 3.14, which is say a decimal notation, which is nothing but a real number. So here you can see that we have specified only integer. So therefore, another one restriction is arrays do not support real numbers. They do not support real numbers. So that is another one thing, another one restrictions when you're using arrays in Verilog. Verilog supports only for these data types. It does not support arrays for the different data types. Now, if we are speaking of arrays, how do we access any element of an array, or how do we access an array? So these are the things what we have to look out for. The first thing is uh, accessing the array. So how do I go ahead? I make use of this syntax in order to access the array. That is array name, and in square bracket you have to put the subscript name. So we'll just see an example on how it is done. Now in C programming and C++, we have seen that you declare array as say 2 comma 2, which is multidimensional. Again, you have something in this form, which is three-dimensional. So these are multidimensional. In Verilog, we do not have multidimensional arrays. It is not used in Verilog. It is not supported in Verilog. So this is another restrictions when we are going for arrays. So we should be careful when we are dealing with such kind of elements. So multidimensional arrays are not supported in Verilog. Now, another thing to just go ahead is before going further is what will be the difference between the net or the register vector and an array. Now, previously we had seen that we had declared some wire that is the net data type with the help of the keyword wire. We specified something w1 and then we gave some number. So this also appears as though it is array, but what is the difference between this net and the register vector? What's the difference between these two and the array? That is what we have to understand. So even we had declared some register 3 is to 0. So there is some difference with respect to this if I have to specify it as an array. So here one thing to note down is net or register vectors basically is a single element. It is a single element supporting data type. But when we go in these types, what would happen is this would be a combination of the number of bits which is specified over here. So R1 I have specified as 3 is to 0. So it is a 4-bit sequence number. It's a 4-bit sequence number. Even here, what happens is this is also, say, if it is 3 is to 0, this also is 4-bit in its width. So indirectly, this is giving you the width information. This is giving you the width information. It is not telling that these many elements are present in this. It is not specifying in that form. So that is the first this thing what you have to consider. Now, as per the definition, when we look after an array is basically a collection of multiple elements that can be either 1 bit in its length or more than 1 bit in its length. So if I just specify, so let me specify that this is the array which is present. So in this one, I can have say only 1 bit element stored. It is only 1 bit. So it may be 0 or 1. So this is an array which is actually holding only one bit each. Now I can have this array to hold 2 bits. So this is also an array, but this kind of feature will not be available in this, wherein you are just specifying as reg say R1 3 is to 0. So in this one, what happens is you have 4 locations, you have 4 places. So in each place, only 1 bit is permitted. Only 1 bit is permitted. But here, what is happening is in a given location, you can have either 1 bit or more than 1 bit. So this will give me say one number. This will give me another number. This one will give me another number. So this is a say 3 numbers are there. These 3 numbers together will give me the array. So that is one of the major difference between the vectors and the arrays, I could say. So vectors and arrays. Vectors, that is each this thing will be supporting only 1 bit. Now, but in arrays, I can have 1 or more than 1 bit. I'm not specifying in terms of location. I'm specifying that what if I'm specifying it as 3 is to 0, it implies that there are 4 elements. There are 4 elements, but the same thing if I specify here, it implies that there are 4 bits. There are 4 bits. These elements, each element can be of 1 bit in length, or it can be greater than 1 bit. It can be more than 1 bit. So that is what I could specify. So here you are specifying it in terms of bits. Say if it is, it can be either 1 bit, 10 bit, it depends. Vector is more than 1 bit. So it can be n bit this thing. But in this one, each element can be of n bit in its length. So that is the case. So that is what we have specified. Net or register vectors is a single element that is n bits wide. That is what we are specifying. R1 is a single element and it is having 4 bits and it is 4 bits wide. So that is the first case what we have specified. And the arrays, what would happen is it is a collection of multiple elements. So I can have collection of register data types. I can have collection of register data types. Each can be either 1 bit or more than 1 bit. So any queries over here? So integer we have count, which is containing 8 variables. This looks similar to your vector, but I am considering it as an array of 32-bit boolean. Here it is a timer. Here it is a timing data type. There are 100 timing checkpoints in this case. Now the special case is this one. So how do you read it? I have ID, which is of the type register data type. But what happens is each port ID is of 5 bits. Each port ID is of 5 bits. So how many elements of port ID do I have? So that is given here. That is, I am having 8 port ID elements. I'm having 8 port ID elements. So these are just a few examples over here, what we have. So next we have, see what we have done is, here he has specified that a multidimensional array. So this is not permitted. You cannot have a multidimensional array in Verilog. Then if I want to access, say, one specific element in an array, how do I access it? So I give the array name is count, and I want to access, say, the element at 5th position. So for starting position is 0, 1, 2, so on up to 5, 6, and 7. I want to access the element in the specific this thing. So I make use of the index 5. So it will give me the 5th element of the array, 5th element in the sense at this specific location. So similarly, I can access any of these. So here you have port ID 3, third element of the port ID array. This is a 5-bit value. So you'll be having multiple port IDs. So in that third one you are accessing, say suppose if it is 1, 2, 3, third one I am accessing. So this is how it is happening. So this is for the vector data type, vector register data types. Okay. So this is what it means. So in this one, I am having 5 bits port ID and I am having 8 port IDs total. So I am having 8 port IDs. In that port ID 3 I want to access. So when I access this, I'll be getting a 5 bits of information. That is this information which is there. I'll be getting that information over here. So next one which comes is this is the arrays data type. Next we have memories. So what happens is since you are going for hardware description, what happens is you always require memory uh, when you are dealing. So memory is nothing but the flip-flops what you are dealing. So how do I go ahead with the simulation aspect? So RAM and ROM. So these things, how do I model them? So we have to model them with some special things, that is using the registers itself, array of registers. We don't have any special element over there. If we define array of registers and those itself can be simulated or modeled as memories. So we have memories. So these are nothing but register files. These are nothing but register files. So we can have RAMs and ROM. We can basically model them in Verilog. So how do I model them? I model them with the help of array of registers. So what we have discussed previously. In this case, what happens is each element in the array is known as a word. So previously we had declared over there, right? Register some number, then port ID and some number. So it was telling that I have registers of 5 bits, that is the previous case, and I have total 8 port IDs. So there are 8 words which are present in this example. So each element is specified as a word. So this is the case which we have discussed in the previous slide. So that is this case. So we have total 8 words in this case, which are of length 5 bits. So each can be either 1 bit or more bits. So previous case we had discussed that it is of 5 bits in its length. If I don't specify anything, it will be directly just 1 bit. So memory, when we specify memory is associated with the address. So if I want to fetch the information from that location, I'll be making use of that address. So in this case, if I'll be fetching the word what we specify. That is the word which is present we'll be accessing. So we had written something as say a port ID 5 or 3 we had written, right? We are accessing a specific word from that set. So in the previous case, so that is what we have checked out. So in order to access that, that address will be utilized. So here you can just see. So we have a reg mem 1 bit. So this is a memory which is of 1 bit each. So I have how many of them? I have 1024 of them. So which is in your binary, we call it as 1K bit words. We have a memory which is termed as, this is the identifier, mem 1 bit, and it is of 1 bit each. So here I am having total of say 1024 words, and each word is 1 bit in its length. So similarly in this case, if I just say mem byte, so here what we are doing, we are taking 8 bits, so it turns out to be 1 byte. So this mem byte is using 8 bits of space. That is, it is consuming 8 bits, or it is 8 bits in its length. So which is 1 byte, and those are 1024 of them are present. So it is how many? 1K 8 bits of length each. There are 1024 words, 1024 words in the sense, this case, 1024 words, and each is of this length. Each is of 8 bits length. Now, if I want to access a specific byte here, if I want to access a specific byte here, so that is what I have to make use of the address. So address is specified by this number, which is falling within the range over here. So when I specify this, what happens is I'll be getting a 8-bit word, since that mem byte is 8-bit. So it basically fetches 1 byte of word whose address is given by 511, and mem byte is the identifier. So in mem byte, what is at location 511? So that is what we are specifying. Don't compare it with the address, this thing what you have, the physical address bus what you have. So what you're doing is here address, what we are specifying is indirectly the index of that element, index in that array. That is what we are specifying. So next one is the parameters. So what does a parameter specify? Now we can see that we can have constants which are defined in the modules, which are basically used with the help of parameter. So parameter helps us to define few of the constants in Verilog module. Now what happens is if you are declaring a variable, say in C programming, we define int I. So I is a variable. Now, if I declare it as a constant, what happens is this one, what I could do is I can have something as I is equal to I plus 1 or I minus 1. I can do some operations like this. But if I declare it as a constant, right, what would happen is it would retain its value. I cannot do such kind of operations. I cannot do such kind of operations. So what does this specify is if I declare some of the parameters as constants, if I declare some elements as constants, I cannot use them the way I use the variables, the way I use them. Okay. So that is one thing what we have to remember when we are dealing with parameters. But again, some special conditions will be there. So we'll just check out those. They cannot be used as variables. The parameter values in each of the instance will be overridden during the compile time. It will be overridden during the compile time. So whenever you compile and a module instance is provided, so at that time, the value which is present in that parameter will be overridden. So next, module definitions can be written in terms of parameters. So what is this? We'll just check out in the later part of the module, later part of the syllabus. So here, what happens is whenever you are dealing with coding, whenever you are dealing with coding, constants are really helpful. For example, if you're say trying to estimate some equation which is using say acceleration, that is gravity, this thing which is constant. So what happens is in such cases, instead of writing everywhere the same thing or the speed of light, for example, the best one is the speed of light. That is, it is 3 into 10 raised to 8 meters per second. So this is an exponential number, and storing this number every time and taking it. So imagine that you have to utilize this number at multiple locations in your code. So instead of writing everywhere 3 into 10 raised to 8, then say plus something or minus something or into something. So instead of writing this every time, what we do is, since its value will not be changing, I declare it as a parameter and then use it. So what you're doing is basically you are trying to avoid the hard coding over these places. So generally when you're programming, hard coding is not good practice. Is not good practice. Hard coding in the sense using the values directly, such as 3 into 10 raised to 8 or some other values. If I have to use 9.1, so I cannot, it is not good practice to use these kind of values. You do not go for hard coding aspects. So again, in debugging also, it creates problem. If some errors are there, then at all the locations, if I have to change, then it will be a big problem. So if I declare it at one location, if instead of three this thing I want to use 2.99, so change it at one location, and it will be rectified in all the locations instead of changing it at all the locations. Hence, hard coding should be avoided when you are doing coding. So that is what it will be helpful. Now parameters can be changed at what all instances. We can change the parameters at module instance, or we have uh, another one keyword which specifies the define parameter statement. We have a keyword which specifies this. So at module instantiation, we can change the parameter value, or at def param. Using this one, I can change the parameter value. Parameters usage makes the module definition flexible. So that is hard coding what I specified, right? So in such kind of cases, if I have to, previously I was using say 2.3 into 10 raised to 8. Now I want to change it to 2.99 into 10 raised to 8. If I declare this as a parameter, it is more than sufficient. It will be reflected in where all it has been used. instead of using this value directly, that is specifying that 3 into 10 raised to 8 has to multiplied with some n1, or it has to be subtracted, added. So imagine if there are hundreds of these, then I want, instead of 3, I want it as 2.9, and you have to go and change at every location. So that is what we can look out when we are dealing with parameters. It can also alter the module behavior, that is how it is dealing with the constants which are present in these cases, that is in the digital circuits. So this is how we declare or define a parameter with the keyword parameter, say port ID. Port ID is the identifier, which is equal to 5. Now it is a constant. Now here another parameter they have defined, which is 256. So it is a constant which is defining a using this keyword. So this is related to the parameters data type. Next we have uh, strings. So how we deal in strings in C programming, similar kind of aspect we can look ahead in Verilog. It basically with some difference, with some slight difference. So strings, they can be stored in the form of reg data type. It can be stored in that form. Now width of the register, what will be the width of that register variables which we are basically using to store the strings. So what it is specifying is I can use reg data types to hold strings, but strings, as I specify, it can be of variable size. Say if I want to specify hello, then what should each character bit length be? What should each character bit length be? So we should be able to specify the width of this. We should be able to specify the width. So this is where your array also comes into play. So here we have width of the register variables must be large enough to hold the string. So here what happens is if the register is just this much, then if I try to write something over there, what will happen is the other things might not be stored. So you should take care that the length of this register data type is sufficient enough to hold the string information. So here what happens is each character, generally when we speak, each character will be consuming around 8 bits. It will be consuming around 8 bits. So in this case, then how do I go ahead with the specification? So previously we dealt with something as reg, we defined and we gave the data type. So what does, say I'll just specify it as R1. Say I'll write it as, say if I write it as 7 is to 0. So what is this specifying? This is specifying that I have a register data type which is named R1, and each one is of 8 bits in its length. So this is how I can go ahead and see how we can store this information. Now slight difference, if I am incorporating in this, then I'll be able to store a string. I'll be able to store a string information. Since again strings are nothing but again combinations of zeros and ones. So that is, therefore we can store it in that form. So here each character in the string consumes 8 bits. Now, what if the width of the register is greater than the string size? So what happens? So these are just a few queries which can come in. So the what happens is bits which are to the that is the bits to the left, bits of the string are filled with 0. That is, width of the register is greater than 0. Greater than the string size. So you start to store, and to the left of these bits it will be stored with 0. That is what he specifies. Now what if it is the other case? Register is smaller but the string size is larger, then naturally some of the string information will be lost. So what part will be lost? Leftmost bits of the strings will be truncated. So in this case, this is what happens. Now, there are some special characters what we deal. So how we can go ahead with displaying those. So for example, I want to put, so there is a hello, and I want a enter over here, and then I want to specify hello world. So this slash n which is there, so can it be a part of this string? So if that is there, it should be identified that this is a special character which is telling that you have to press enter, or it has to go to the new line. It has to go to the new line and then type the rest of. Say if I am printing it, it should print hello, go to the new line, and then print world. So this is how it should go around. So we make use of what is called as escape characters, which can be displayed. So these are the special characters which can be used for displaying the string. It can make the readability much better. So that is what we can just check out. So here we have register, slight modification of this specification, string value. So this is a string value which is related to register data type, but each string value is how many bits? So you can see that it is of 18 bits wide. So here you can see that it is 8 into 18. So this is 8 bits. How many 8 bits location? 18. So I have 18 elements, or I have 18 bytes which have been specified over there. So each this thing 88 bits, and they are 18 in number. So declare a variable that is 18 bits wide. 18 bits wide. So that this is what is specified over here. So and if I want to assign a value to this, this is how I assign. So this is 18 bits wide. So you have to just check out whether this thing will be supported in this case or not. So here string value, each location is 18 bits wide. And since we are specifying is to one, only I'll be having say 2 locations over there. So this is how it goes around. So any queries over here? So this actually completes data